Welcome back. This is a video series for the lecture 3 slides. This is video 3. I'm going to finish up with some things from the previous video with the integer class Arithmetic Overflow, but primarily this will be on compound operators and increment and decrement operators. So we left off from the last video talking about the integer min and max value. And so this is some test output. So we had looked at this integer min and max value. These are constants provided in the integer class, so we can see the smallest and the biggest values that can be stored in an int. We can see that if we take an int value like this and we add 1 to it, rather than getting 214783648, we're now getting negative 214. So integer values, they have, the computer has a finite amount of storage, and if you try to store a number that's bigger than that storage, it's called arithmetic overflow, and it's not a compiler error. It doesn't quit your program. You just get output that is incorrect. This is certainly not this value plus 1. That's what this should have been. So we're getting this overflow where it's too big for the storage area, and so we're getting weird results and we're getting a different number. It's just showing us that piece of the integer. So had I put it in a variable here, so this is the test variable holding that value, and you can see it here. The same thing if I were to put it in this variable and then add 1, I'm going to see when I run it, we're going to see that it also overflows. So these two last pieces of output here correspond to this code in the code. So one way we can fix that is to use a long. Long is beyond the scope of the course, and we don't use long that often. And so this is just for your information to see that long is able to, let me see. So I want test to not overflow when I do this, sorry. And I could have just, so here is test with its max value of integer. This is 2.14 billion. And then I take that value and I add 300 to it. But if I take that value and I force it to be a long and then I print it, then I'm going to see that that 300 got added. So this has a long has a much bigger range. It can store a much bigger number. For most of what we do this year, integer is fine. And so we're kind of aware of long, but we don't really use it. It is beyond the scope of this course. So the main part of this video is actually about these compound operators. So we have these shorthand or shortcuts we can use where it combines something. So if I have a variable and I want to take its value and I want to add something to it, rather than writing the variable name equals the variable name plus value, I can use this shorthand notation of plus equal. So I can do that with any of my math operators. This is the longhand version of it. This is what you should be thinking in your head. When you see this, this is what you might write on paper if you have it on a paper. I will often do this on paper myself just to make sure I get it in my head straight. So x plus equals 3 means take the variable x, add 3 to it, and then store that result back in x. So another shorthand operator that we have is an increment and a decrement. So rather than saying a variable equals its value plus 1, we can just use this plus plus. So that's the same as adding 1 to a variable. So similarly, it's the same as if I said variable plus equal 1. So I could use one of these shorthand notations. So there's like 3 different ways for me to add 1 or subtract 1 from a variable. It's something that's done in programs frequently, and so we have this shorthand notation of plus, plus, and minus, minus. It goes after the variable. It means something different if it goes before the variable, and that is beyond the scope of the course. So we always have the increment and decrement after. I can use it with ints and doubles. It just takes the value of the variable and subtracts 1 or adds 1 to it. So we had a previous code tracing example that I walked through using the debugger. I'm going to do it again. It's the exact same code from the last video, except that now I'm using some of these shorthand operators. So here in the code, I have it here in part 6 where it's using the shorthand. So I'm going to make this so that we execute part 6. And to use the debugger, I'm going to put a stop sign right here because that's where I want my program to stop. I'm going to recompile, and it's going to come here to, where is it? Oh, I hit run, I didn't hit debug. So if I want to debug, I hit debug. There we go. There, now it stops at my stop sign. So I'm going to step through. I'm going to do it a little bit faster since we did it in the last video. So x gets the value 0, y gets the value 5, z gets the value 1. X plus plus is the same as x equals x plus 1. So I'm going to see this value for x go from a 0 to a 1. Y equals y minus 3 here. That's what that minus equals means. And so again, when you're new, if you see that on paper or anywhere else, writing out the longhand notation for yourself helps. So y is 5. 5 minus 3 is 2. So y is going to get the value of 2. Z equals x plus z, which is 1 plus 1. So z is going to get the value of 2. X equals y times z. Y and z are both 2. So that's going to be 2 times 2 is 4. So x gets the value 4 once I execute that line. This is y equals itself mod 2. Y right now is 2. 2 mod 2 is 0. The remainder is 0 after I divide 2 by 2. So that 0 is going to go into y. So I'm going to see this value of y, the 2, change to a 0. I'm going to decrement 1 from z, subtract 1 from z, so z will be 1. And then I'm going to print the 3 values as before. So we will get some more practice in class with these operations. I think the hardest part is going slowly on paper, especially when the computer does it so quickly. And so for us, it's going to take us a little more time to do it. All right, well, happy coding. I'll see you in the next video.